Hi, welcome. In this video, we're going to start on the concepts from Module 4 and talk about functions and procedural abstraction. So let's get started. So down here in the instructional materials, we're going to go through these notes and then we're going to do some examples. So I've already downloaded the notes, so let's just talk a little bit about functions. So it's very important, and hopefully you guys are familiar with what a function is. A function is like its own little sub-program. So in C, we were always making our functions, and I was giving you the information to make your functions, and you were practicing using your user-defined functions. But they're actually not called user-defined functions. They're actually programmer-defined functions, because you're the programmer and you are creating those functions. So functions can have more than one argument. And if you've started, and hopefully you're already working on program 2, you will notice that there are pass by value arguments and there are pass by reference arguments. And in C++, it's a little bit different how pass by reference arguments or formal parameters work. And so hopefully you're getting a concept of and the idea of how that works. Those are what the purpose of programming assignments is, to practice things and learn by doing. So functions, when you call a function, the function call is an expression. So just like you have mathematical expressions or you have Boole expressions in conditions and loops, you also a function call is also an expression as well. So if you recall, an expression is just a set of instructions that include numbers, values, whatever, that returns a value. So just take a look here. This right here, this is a mathematical expression. So after you take your budget and you divide it by cost per square foot, in the end, you're going to have a result. That is an expression. That's called a mathematical expression. I want to point out here that cost per square foot has been defined here in our main function as a constant. So you could define it here inside the block of code of the main function, or this could have been defined, because it's a constant, it could have been defined globally. We do not use global variables in this course, but we can use global constants. So again, this is an expression. After this budget gets divided by the cost per square foot, there will be a result. And that result will then be assigned to area. A function call, which this square root function right here, a function call is also an expression. So when you call the square root function here and you pass it the area, that is that's not a void function. That's a function that returns a value. So that value will then be returned. So that function call is also a type of an expression. And that's part of the math. It's actually part of the C math. So in C, we would do pound include math.h, but in C++, if you want to include C math functions or C math libraries, you don't put math.h, you put a C in front of the name of the library. So it's pound include C math, and this square root is a function that is not a programmer-defined function. It's a function part of math.h library. All right, so let's go back to our notes here. All right, so that's a predefined function. Those predefined functions are functions that are part of a library. So many of the libraries that you use predefined functions are part of names that are in the standard namespace. So of course, you want to make sure that you include the standard namespace. If you include the standard namespace globally in your program, it will become available to everywhere in your program. So even though this is all part of the main function, from the opening curly brace to the closing curly brace, that's the scope of the main function. So anything that's inside of those curly braces is only available inside your main function. This doesn't have any programmer functions here. If you put anything globally up here, that is available to your whole programs. And we'll take a little more look in detail. Let's look at the next code. So I've gone ahead and downloaded. So let's take a look at a call by value functions. All right, we'll go back to the notes and then we will come back here to this call by value. All right, so functions have a function prototype, a function definition, and a function code. So a function call. The function call is the expression. The function call is the statement in which you invoke the function. You make function calls to programmer-defined functions that you define yourself. You also, just like we did with square root, you make function calls to library functions that belong to a library. The function definition, that is the implementation of the function. So that's the block of code in which you write if it's a programmer-defined function, you write that block of code. In the case of the square root function, which it was a library function, that definition is included in the library, and you don't see that definition. You don't need to see that definition. And what you want to learn how to do is you want to learn how to write your definitions and write your prototypes or declarations in such a way that that the user, anyone who wants to use your function, does not need to see your definition in order to use it. So that's why we're practicing using preconditions and postconditions and a description. So in all of your assignments that have programmer-defined functions, anyone should be able to take a look at your prototypes and be able to understand how to use that function. So you want to practice writing your preconditions, your postconditions, and your declarations. So so take that very seriously while you're working on your assignments. So let's take a look here. This is a function. So this is a function called total cost. So actually here I should have a precondition, a postcondition, and a description. So what does this function do? So this function is, it gets the cost and the number of items and returns the total. So it takes the cost, and the number of items and returns the total cost with the tax included. All right. So what's the precondition? In order to use this function, what must be true? Well, I must have an int. I must have values. There must be values for an int and a double. So in order to use this function, I must have values for an int and a double. And the int is the number of items, and the double, I'm assuming, is the cost. And what's the post condition? It's going to return, since it has a return type, it's going to return the total cost with the tax included. So it will the post condition is that the total cost will be calculated with the tax included. So again, you need to practice writing your preconditions, your postconditions, but just as a rule, just think about it. I want to be able to look at this function and say, all right, this function is available to me. It's called total cost. And what do I need in order to use it? All I need to have is a number of items and a double, and I pass that to it, and it's going to return the total cost with the tax included. So that's the post condition, and the total cost will be and return. And it's a little overkill with the description and the pre and the post, but it's better to have more information in your prototype than less. So through practice, you will get better at streamlining your comments and making them easier to understand. So that's why we do assignments, so that we practice. So if you go down here, I should not even I should not even have to look at this implementation down here in order to use it, right? So maybe the tax rate here. So the tax rate is 5%. So that's going to, what it's going to do, it's going to, with the tax, so we have to say the tax is 5%, because the tax in here is 5%. I shouldn't have to look at this function definition to discover what the tax rate is. That should all be available to me in the comments that describe the prototype. This is the whole focus of understanding that functions should be their own little sub program. And I know this is a very simple function, but the idea is the same no matter if you are doing really complicated functions or simple functions. A function should be its own little subprogram. And then the main function, so really how you implement your code is that you take these, you break up you understand your problem, you understand what you need to solve, and then you break it up into sub-problems. And then you implement each sub-problem separately. So each function, so if this program was going to have 4 or 5 functions, the steps in order to implement this would be to implement my sub-programs and my functions one at a time, and then use my main function as a driver to test each function as I'm working on it. So you need to learn these terms, driver. You need to learn that functions are sub-programs. You need to understand that your function prototype or your function declaration, it could also be called a declaration, that is just a statement with a bunch of comments that describes how to use that function. So your program 4, you're going to have to write a few functions, and you're going to implement them one at a time, and your main function will be the driver to test those functions along the way. And you could also make stub functions as well. Stub functions are those functions that are incomplete but are needed in order to test your functions. So sometimes you don't just use a driver. A driver is the function that will allow you to call your function and see if it works. And it might not be part of your complete program, might not be complete. And then you have stub functions, which are sometimes incomplete function implementations that are used as like helpers to try to implement your function. But you should be doing one thing at a time, doing your little sub programs at a time. They should exist on their own. By the end of the semester, we're going to be creating full classes in separate compilation in different with functions in different files. So we're just getting started here to understand and reiterate these concepts that were introduced in your Introduction to Programming course. All right, so this is what I just said. Calling a function is like running its own small program. The function input, so when you call the function, you pass it arguments. So here, when I call this function total cost, these are the arguments that go to the function. When I define my function, these are called formal parameters. These two formal parameters are passed by value. So in order to pass anything to this function, it must have a value. I cannot declare this, and hopefully it will give me an error. So if I try to declare price and number and pass them to this function, they have no values, and this is a pass by value function, so it should not work. I don't know if my compiler may not pick it up, and which it did, but some compilers, particularly older compilers, would never let you know that. They would never give you so much feedback, but Visual Studio now is letting you know that I have not assigned any values to number or price. And so therefore, when this function gets called and this number gets declared, it has no value. So how is it going to do any type of calculation? And when this price gets declared, it has no value. So this price right here has no value, and this number has no value. So this mathematical expression has no value, so no calculation can be done. So you need to make sure that when you're using pass by value parameters, that your arguments actually have a value. All right, so function can return any data type. In our class, we have the options for our function to return are integer, int return type, double return type, char return type, and we also are going to be practicing using functions that return a bool value, so that when that function is called, that expression of that function will only have two values to return, either true or false. And a function that returns a bool value is called a predicate. All right, so function parameters can be by reference or by value. Right now we're just practicing by value, but in your program 4, in your program 2, and in your program 3, you do practice doing pass by reference parameters. So call by value, they use a substitution process. So just like here in this number right here is local to the main function, and this price right here is local to the main function. So when it's called, whatever value number has is going to get passed. So if number has the value 10, then the 10 would be passed here. If price has the value 350, then 350 would be passed here. Then number would get declared and assign that value, and price would get declared and assign that value. So I'm just going to change these names just to reiterate that these variables are local to this function.